Hello. So last time we started our introduction to the science of where, or how to think spatially, and we had an introduction. This lecture is going to concentrate more on why is spatial thinking important to us. So let's think about that. Lots and lots of reasons why spatial thinking is important. As we alluded to in the introductory lecture, spatial thinking is at the heart of many scientific discoveries. We'll look at some of those in this lecture. It also underpins many activities of today's modern workforce, and really, it's there. It's ubiquitous. It pervades everything that we do, and as you get more and more aware of spatial thinking through going through these lectures, I think you'll see that almost everything you do could have a spatial thinking component to it. So, as a result of this study done by the National Academy, and they produced this document, this report that I've asked you to download if you want, called Learning to Think Spatially. The committee, the group that did this research, came up with some conclusions. And one of them is that spatial thinking is fundamentally important. But even more than that, and probably what's more interesting than that, is that spatial thinking has not just been under-supported over the last 20, 30 years, but it's also underappreciated, undervalued, and under-instructed, and hence my motivation for putting together these video lectures. So again, we thought about this, we talked about this a little bit last time, but maybe you're familiar with this, maybe you're not, but Watson and Crick, two scientists in the UK, used spatial thinking to come up with the idea of what DNA looks like. And obviously we're so far past that at this point, but if they had never done this, you need these fundamental breakthroughs to actually begin learning more and more and more about things. And so what's really cool is they were able to reason out this 3D structure of DNA from some really fairly poor experimental data and some 2D images that were quite blurry. You can really look into this, and it's really, really interesting. And it turns out once we actually had the imagery and the knowledge, the technology, to know if they were right or wrong, it turned out that they were right in both distance and in scale. And so their achievement is considered an intellectual tour de force, which is very impressive and still important, 50, 60, 70 years later, where we're there, okay? And so they even grasped the concept of copying the mechanism for the genetic material. And so an intellectual tour de force. Spatial thinking probably at its finest. Okay. So here I want to just review and go over the Learning to Think Spatially report and emphasize the different components of it. So if you've downloaded that, great. If you haven't at this point, maybe this will motivate you to do it. If not, it's not absolutely key. It's just a place where you can get more information. And so what you can see here is that I've listed the chapters and sections that allude to these different statements. Okay, so helps us understand a little bit more, maybe a little bit more of a review from last lecture on what spatial thinking is all about. So spatial thinking from chapter 1, section 2 of the Learning to Think Spatially book, collection of cognitive skills that combines the concepts of space, tools of representation, and processes of learning. So you'll hear that terminology a lot. Chapter 2 emphasizes that spatial thinking is integral, it's ubiquitous, it's in our everyday life, and it must be understood in terms of locations, distances, directions, shapes, patterns, all the things you can think of when you think about spatially. Okay. Also, chapter 2 talks about how it's powerful for solving problems, for managing, transforming, and analyzing complex and large data sets, This is big these days. Now, a lot of times these days we're doing this on the computer, but I don't know about you. I'm not a big fan of putting everything in a computer, pushing a button and hoping that the computer um, does the right thing, right? I like to have some understanding of what's going on. So, um, and then chapter 3, we get into how spatial thinking is critical for everyday work of scientists, engineers, and how it's been a catalyst of many of the breakthroughs, including what we know about DNA. Okay. So I'll go a little further on. We understand that spatial thinking is a skill that can and should be learned by everyone. And that's in chapters 2 and 4, and then also in an appendix. And we learned last time that there are different levels or of ability. At the same time, they can all be improved. And in chapter 4 and appendix C also talks about the uniqueness of different individuals based on their experience, based on their education, and kind of based on desire or inclination. And then chapter 4 also talks about the different disciplines, how the fact that spatial thinking is not limited to a single discipline, but it crosses all disciplines, all domains. That's why I went from STEM to STEAM in our last lecture. And then it can be developed specifically in a discipline. Okay, so if you're a geographer, you understand certain spatial thinking concepts. If you're an artist, you may have other ones. If you're a mechanical engineer, you may have other specific context for your discipline, and that's totally fine. And we also know that having it in a discipline can help you extend it beyond the discipline. So chapters 3 and 4 talk about that. And again, chapter 4, transferable. So as I just said, you can go from one domain to another. It's really kind of across many different ways, many different disciplines, many different work settings or things that your work have. Okay. And then chapter 5 kind of pushes the recommendations and talks about how spatial thinking is really not taught at all in any systematic way in K through 12 or in any other curriculums, despite its fundamental importance. Okay, and so this is an issue. I think this is important for me from that standpoint as a professor in remote sensing and geospatial technologies. Obviously, this is key for me, and as I teach my geospatial courses, I find that students are not really thinking about this the way that they could be and the way that they could help them. So very important. So anyway, that's what that book covers in case you're interested in that. Okay. So what are we going to do from now on? Well, what I want to make sure that the rest of the lectures do is help us understand why spatial thinking is so important. Give us some idea of the basics of spatial thinking. Give us some hands-on learning or practice with some exercises. Hopefully you did exercise number 1, and some of those maybe were very easy for you, and some of them were pretty tricky. That's okay. Don't worry about that. We want to make sure we get an idea of the breadth of disciplines that use spatial thinking. And then probably the biggest goal is to make sure that you feel like you can start applying spatial thinking to your own experience, your own field of study, make it real for you. I'm a big fan of making things practical, making things real. And so then with that in mind, then you hopefully will improve your spatial analysis skills for the rest of your life, and you would describe yourself as a spatially literate person. That would be great if you get that out of these lectures. Okay. So, as we know, spatial thinking is sort of a basic and essential skill. Hopefully you're convinced of that at this point. We know that it can be learned, so that's important. It's not a natural gift that you get, but it's something that you can learn. It can be taught formally to anyone, and it needs to be supported by the appropriate tools, technology, curricula, whatever you want to think of there in order to continue to develop it. Okay. It's not simply a bunch of tools. Okay. There are tools that's part of spatial thinking, but those tools sort of are synergistic. They come together. The tools are a means to an end. They're necessary, but they're not sufficient, right? It's more than just tools. Okay. And currently, we don't have any standards or reliable assessments for evaluation. There's the test that you did for exercise number one, but that's just a partial piece of a test that's really not testing all of your spatial thinking, right? Okay. So important to understand what spatial thinking is not. Okay. It's not content based. Again, there can be specific components of spatial thinking for a specific discipline, but it's bigger than that. Okay. It's not like studying physics or not like studying biology or not like studying economics. It's like something much, much bigger. It encompasses all those things. It's not a standalone subject. Okay. And it's not simply an add-on. It's something that should be integral. It should be part of everything. It's more like, from a student standpoint, learning to write, right? You don't learn to write just in English class. Hopefully you learn to write in all your different subjects because you're creating papers, you're doing essays, you're explaining things. It's kind of a component of everything. Okay. And so hopefully spatial thinking is sort of like a lever that helps you to achieve a deeper and more insightful understanding, whatever you're doing. That's the goal. So it's important not to pigeonhole it into a specific place. Okay. So I like this a lot. I think we struggle with that these days, but there's this challenge to learn, not challenge to know, not challenge to memorize, but a challenge to learn and a challenge to think. And there was a 20th century psychologist who was part of the cognition revolution. His name was Jerome Bruner, and there's a picture of him there. And he said that we must challenge ourselves to learn and to think. And he contrasted that with this passivity of knowledge getting, where you just memorize things, or worse yet, you use your phone, right? And you ask Google, or you ask Siri, or you ask, whatever, whoever. I guess it's more like whatever these days. And we get our knowledge, but we're not synthesizing things. We're not learning to think. We're not actually perhaps even learning. We're just kind of gathering knowledge, but there's a difference. And he claimed that thinking is a reward for learning. In other words, you're synthesizing that knowledge and you're putting it together. And one of the examples that he used were these two groups of fifth graders, and they were learning about geography. One was learning it as a set of rational acts using induction, using active learning, looking at where things were and how they related to each other and how they were connected. A lot of spatial information being given there. And the other group was given a bunch of arbitrary facts that they memorized, the names and positions of things. And they wanted to know which group actually learned, which group was taught to think versus the group that just memorized stuff. And I'm sure you understand the answer to that. So I think that's a big deal. And I think as we get more and more technology dependent, we get a little lazier about actually thinking and learning. And so that's super important. All right. So what's the challenge? The challenge is for all of us to become spatially literate, to grow in our ability to that. If we're going to do that, we need to appreciate the benefits of spatial thinking. So hopefully you will get some of that out of these lectures so that you have this appreciation, this awareness, and then the desire to grow in that. Okay. And so the understanding and appreciation of the concepts of spatial thinking, coupled with some hands-on exercises, essentially 3 exercises in this lecture series, but actually you'll do exercise 1 twice, so we could actually say there's 4. But there's so many more. Okay. If you go to the internet, if you go to your apps on your phone, if you any place, okay, you'll find so many examples of how you can improve spatial thinking. Okay, some of them are, most of them, a lot of them are free, especially a lot of the games. Some of them you have to pay for. Okay, but anyone with the necessary desire can definitely improve their spatial thinking abilities. And hopefully, because it's games, because you're not even realizing that you're thinking spatially until you get this awareness from these lectures, it can be lots of fun. So you want to make sure that you're doing that. So next time, lecture number 3, no exercise this time. We'll get to another exercise shortly, but I'll see you for lecture number 3. Thanks.